to Math in the PM. We don't have a name yet. I'm not going to just say we're M&M or something, 50 Cent. That's somebody else's name. We're going to use it to inspire. Anyway, we're currently in progress. Grade 9 math. We've written down chapter 2. If you're just joining us on record, put this title down, Powers and Exponent Laws. I have this example here, and we're going to take a look at it together. These are the parts. Grade 8 and stuff. Do you guys do things with exponents every once in a while? We'll do the number at the top. The whole thing is called the power. That's why the bar. I'm not too worried. But that's the power, 5 to the 3. The 3 is the exponent, right? And the base is the 5. Do this. That's 5. Is this 5 even look down? On there. Okay. Now, the words, that's vocabulary. That's not math. What does that mean? 5 to the 3 doesn't mean 5 times 3. It means 5, 5, 5. You write it down 3 times and multiply it more. You do it in your head, great. It gets pretty big fast. You can calculate it. 5 times 5 is 25 times the number 500. That's how you do it. If you have a calculator with the button, you'll find it wrong. You can do it that way. But I'm going to want you to know that repeated multiplication is abbreviated basically with this exponent. 5 times 5 times 5. That's okay. Right as a power. That means going from this to that. So let's do a few of these. What would we write down, no? Write down the example. And then we're going to go over them together. And you're going to tell me right now. 6 with an exponent of 4 is exactly right. Change 6 is the base, 4 is the exponent. You can see why this is to your advantage if you have a really long list of 6s. If you had 17 of them, I would not even want to. You can see the connection? Very simple way to start. Try B and C. B is very simple. C isn't bad. It's kind of like a trick. Not much. I'm going to pause the video, give you guys 30 seconds or so to write them down and try. Recording. Here we are. And I'm going to ask you guys, how do I write 3 times 3? Is that a power expression? 3 with the power of 2. Okay. First time. There we go. Now, we say 3 exponent 2, 3 to the power of 2, or does anybody know a shortcut way that doesn't use the word 2 in it? You ever heard of squared? Because you might have done something called the Pythagorean theorem. You take the one side squared plus squared. Why do they call that squared? What does it have to do with the shape? By the way, I am recording. I'm going to just pause for a second. So why would we call it square?
Because it's Pythagorean theorem, you use squares to find out the side of the bottom.
Okay, but Pythagorean theorem is like a triangle.
Yeah, but like the sides times, for all the area, you make the square out of the.
We can draw a square for each.
Yeah.
That's true. It's even simpler than that. What you said is 100% true. You can have 3 squares and the 2 little squares out of it. That's true. But yes, could mean, and not the wrong. If I had, and I'm going to just draw it like rough. Let's say that this is 3 centimeters left and right. This is 3 centimeters tall. Here I can literally count how many little centimeters squared there are. And I'd say, oh yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can count squares. What's the fast way to find how many squares are in this square shape. That's 3 by 3. 3 squared. Yes, 3 times 3 is 9. You guys follow that? Like, if I had something that was 12 by 12, I want the area, I just say 12 squared. And just like you said with the Pythagorean theorem, you got 3 squares going on for each side of the triangle. And that works. And you guys actually, you must have had a teacher that drew that out. Oh, you listen to it. Gosh, you're not listening to 50 Cent. You have nothing about Pythagorean. Okay. Is there something else? Something else to add? Okay. Now, what would I write down for the 12 expression? What's that equal? Nothing I hear, not 12. It is 12. Oh, that's disappearing ink. Don't submit any work in disappearing ink because when I get it, that I won't be able to give you marks. I'd write 12, and I'm going to put an exponent of 1 because it's written once. It means the same thing as you're writing down 12. So it's literally how many 12s I've written down, how many 3s I've written down, how many 6s. I'm actually not to write down green square 3 by 3 because this is a little bit of notes that you're going to just do right now, and I'll get you squares. This is why we use squares the most. Okay. I'll give you a moment to write this down, and it gives you the area of a square. Get something on your paper, but I have in black. Okay. Pause the video while you draw it. Force this off if you haven't already. So, I literally want you to understand the square idea comes from the area of a square. So 1 square means 1 times 1 is 1. And you can see that's literally 1 square, right? This is 4 squares if you count them, but we're not grade 2. We don't need to count things. We know that 2 times 2 is 4. We know that we already talked about this before. 9 squares. Right? If the sides are 3 and 3. So if the sides are 7 and 7, 49, dude, right? Makes sense? Now, if those are squares, what do you think a cube is? Those are exponent 3. Now, I've drawn it in 3D, and I don't know how good your 3D drawing is. Mine's mediocre at best. I'm going to ask you to figure this out. And they describe not area, but volume. How much space something takes up. While you guys are jotting this down, I'm going to get out some cubes. So the 3D drawing part, do your best. But that's what we're trying to do. Let's think about it. So I literally have, I say 1 cube, that means 1 times 1 times 1. Each side is 1. How many actual cubes do I use to make this? 1, right? That's why 1 times 1 times 1 describes. I guess I'll use the color. I'm going to say, what? That's the volume. So if this was a centimeter on each side, what I'm holding, that'd be 1 centimeter cube. CCs, so come here, talk about CCs. Anybody know about motorcycle engines? Oh, they're measuring CC. So hear about it. Motorcycle science. So this one. How many little cubes did I use to build this? I could sit and count. But what's the easier way? 2 times 2 times 2. 2 cubes. 2 times 2 is 4 times another 2 is 8. You can enter that on the calculator. I could do that one. 8. Okay, 2 times 2 is 4 times another 2. That's the volume. How much space is it? It takes up 8 centimeters. 8 centimeters cubed. But this one, and after 3 by 3, There's some inside cues that you can't, and you're gonna assume it's solid, not solid. You can't even count, but how many cubes did I use to make this? 27. 1 plus 3 times 3 times 3. 3 times 3 is 9. Times another 3 is 27. So if I took apart this cube, that's 3 centimeters by 2 centimeters by 3 centimeters in the other direction, I got 27 little cubes. That's what that means. Everybody's aware of this kind of thing? Have you guys played around with measuring volume like this before? 3, 8, 7? No? Who says no? We're building on that idea. For instance, you need to get up and just lively yourself up. What? Where is it? Okay. So now what? Now, I'll write something else. And this page 55, I'm going to write this down. I'm going to hand out something that refers to it. You've already got it. So I'm going to pass the front and then your you're going to try these questions, already explaining them, just handing out grid papers. Today, I want you to do 4, 5, 6 AC. Over it out for the